Assalamualaikum warahmatullahi to our lecturer, Associate Professor Dr. MASDI bin Muhammad. This is the presentation from Group 8. The team members are Nur Faizal, Aina Shahira, Fazlan, Muhammad Haris Mirza, Muhammad Zulkhairi. We will present to you the project analysis from a case study. The outline of this presentation, starting with introduction, objectives, identification of critical equipment, the analysis, and last, conclusion. Introduction. This is a case study on the gas processing plant that has been tasked with the student to analyze the reliability, availability, and maintenance RAM of the equipment in the plant. The study will give a significant impact on the estimated lifetime of the equipment, maintenance forecast on the equipment, therefore saving the higher value in the aspect of cost and risk of an operating plant. For this project, our group has chosen to conduct the study on the prediction of availability of the natural gas processing plant by using BlockSim software. This software has the credibility to estimate the RAM value for the equipment listed for a plant. Now, for this project, we have three objectives. First objective is to identify critical equipment in natural gas processing plant by using the data given. Second, to estimate the average availability of the plant by using BlockSim software. Third, to generate action plans to increase the plant availability to 99%. The assumption of the analysis has been made into three categories. Recurrent data analysis (RDA) is applied in the analysis since the equipment is repairable system. Failure distribution is using Weibull distribution. Repair distribution is using exponential distribution. Repairable system is known as bad as old, since the system is in the same state after repair just as before it fails. For your information, the value to analyze the critical index was processed by BlockSim software, where the RBD block is made in the interface and the value needed for each component is retrieved from the input data for group 18. The data input is very meaningful to determine the study, to come out with RAM analysis, and to predict the condition of the plant. Next, identification of critical equipment. From the analysis in the software, a set of data has been developed from the input information to produce the value for the availability study. A spreadsheet of the block summary has been obtained and the values are interpreted into meaningful information. This table is partition of block summary from BlockSim spreadsheet. As you can see, the highest value for downtime critical index was found in the feed gas separator unit and the mechanizer unit with 12.6 and 12.44% of failure. Two components of lean amine pumps have a value of 12.27% and 16.4% of failure critical index. All these components will be major factors for the whole processing unit of the plant to operate, and any failure or downtime in these components will result in the large scale of cost in operation and business. The red circle shows the location of field gas compression unit in the whole block processing unit. Based on this figure, feed gas separator unit is in series of the block component configuration of the whole unit. Reliability of the feed gas separator unit is expected to be high with a low likelihood of failure and downtime to happen. The mechanizer unit is in the last block in natural gas liquid recovery unit, where it is the end product of the unit line and for the whole processing line to reach the end block. The whole processing unit will be on full operation if the whole system is in complete operation. The lean amine pumps are required to be in 2-2 node of unit line, or else the whole unit of amine regeneration and sulfur recovery unit will be unsuccessful. Now, average availability for the plant. Inherent availability A is considered in computing the average availability value of the plant. A is the probability of the ability of the equipment to be functioned on a specified time given under an ideal condition applied on the system. General function to calculate A is given MTBF over MTBF plus MTTR, where MTBF is mean time between failure and MTBR is mean time to repair. These are the results of the calculation of three critical units: lean, amine pumps, gas feed operator, and the mechanizer. The calculations are based on improvement of MTBF by times 2 and the improvement of MTTR by half. By improving the MTTR value for each component, the availability can be improved significantly compared to increasing mean time between failure. The component has high availability to repair rather than replacing with new equipment once it is failed. Overall availability of the whole plant unit is improved to 97.84% from 97.3% of mean availability in the given data. Now we have come to the action plan to achieve 99% of availability. The graph represents the availability of the critical equipment. Based on the graph displayed, the improvement in increasing the mean time before failure and reducing the time of mean time to repair has a significant gap to achieve until 99% availability of the system. Quality and control check on the new purchasing equipment is a crucial stage in improving the availability of the part. The new receiving part must be in impeccable condition so that the mean time to repair can be reduced. Other than improving the mean time for both operations of the machine, it is advisable to increase the number of equipment for each critical component so that the availability of the component will be higher. Increasing the number of equipment in the system will also improve the line configuration of the system to be more in a parallel line and reduce the probability of failure. As for the conclusion, the availability of the system desired can be achieved by identifying the critical equipment and performing the required analysis. Several alternatives suggested in the analysis will increase the availability of the system. And the study has provided a great insight for students as future engineers to pursue in this line of career. Thank you.